Hello, I'm Dave Harvey, and I'm an electrical engineer here at Proportion Air. And today we're going to talk about resolution and how it relates to other specifications such as accuracy and repeatability. Accuracy, repeatability, and resolution are some of the common specifications for instrumentation products. However, depending on your application, one might be more important than the others. Many sensitive applications are more concerned with resolution and repeatability than absolute accuracy. Resolution is sometimes confused with accuracy, but they are very different. Accuracy deals with how close the indicated value relates to its actual value. On the other hand, resolution is a measure of the smallest change detectable by the sensor or the smallest change that the control system can make. The third term, repeatability, is how close a process is to hitting the same set point consistently cycle to cycle. Now we know the differences among the three specifications. Let's return to resolution, the smallest detectable change. For pressure control using solenoid valves, the best way to get the finest resolution is with an analog sensor and an analog proportional valve, also known as a voltage variable orifice. The proportional valve is capable of throttling flow to the exact amount necessary to maintain your set point under various flow conditions. For the analog pressure sensor, the resolution is theoretically infinite, however is normally masked by noise. Contrast this with a digital valve sensor combination. A standard solenoid valve is digital in nature as it has two states, open and shut. The valve size, supply and working pressures, downstream work volume, and the sensor resolution would determine the final resolution for this setup. For a digital sensor, 14-bit resolution is typical, giving you these finite steps. Additionally, if a valve is energized and immediately de-energized, this results in a small amount of air being introduced into the system. This volume of air will increase the pressure by a fixed amount depending on the downstream volume. The control resolution of this system is the size of that step. How about an illustration? This graph shows the response of two valves responding to a ramp command. They are under flow, filling a volume. One unit is using a traditional digital valve, the other a proportional valve. Note that the unit with the digital valve, whose response is shown in the red dashed line, has to cycle periodically to add media to the system to make up for flow. The blue line shows the proportional unit. The response is smooth, as the valve is positioned to exactly offset the amount of flow and maintain pressure. So long as the flow rate does not exceed the capacity of the valve, you can expect a linear ramp. Something else to mention is hysteresis. For our purposes, it is the difference in result when approaching the set point from two different directions. Hysteresis can be a result of the control scheme used or deliberately added to prevent the unit from hunting around the set point. Our illustration shows the hysteresis of this setup as two gray lines. If the hysteresis is deliberately added to the system, it is often called a deadband. Feedback changes within the deadband do not result in a controller action. From a control standpoint, hysteresis can mask the true resolution of the unit and also affect repeatability. For example, let's say a unit has a pressure sensor and control resolution of 0.1%. However, the unit has a built-in deadband of 1%. For this unit, while the resolution of the sensor and control is very good, it is masked by the deadband, lowering your effective control resolution. A good example of an application where high resolution and smooth operation is required is microfluidics, where small samples are pressurized to move through tiny chambers for analysis or dispensing. Due to the sensitive nature of these applications, a unit with digital steps, hysteresis, or deadband will not work very well. A high-resolution unit is your best choice for optimal performance. That about wraps it up for today with resolution, one of many topics we'll be discussing. Like and subscribe to our channel for more great educational and application videos.